6-6 Systems of linear inequalities. Objectives: to solve system of linear inequalities by graphing, to model real-world situations using systems of linear inequalities. A system of linear inequalities is made up of two or more linear inequalities. A solution of a system of linear inequalities is an ordered pair that makes all the inequalities in the system true. The graph of the system of linear inequalities is the set of points that represents all the solutions of the system. Essential understanding: you can graph the solutions of the system of linear inequalities in the coordinate plane. The graph of the system is the region where the graphs of the individual inequalities overlap. Problem 1. Graphing a system of inequalities. What is the graph of the system? So we have y is equal to 2x minus 3, and 2x plus y is greater than 2. It's easier if the graphs say y and then our inequality symbol. Usually we have y is equal. So y is equal to 2x minus 3. So we need to graph this. But this one we need to subtract 2x from both sides to get it to say y is equal to. So y is greater than negative 2x plus 2. You notice this is a positive 2, so we put plus 2. So when we change this, we have y is equal to negative 2x plus 2. Now it'll be easier to graph. So we take a look here. We have y is equal to 2x minus 3. So at negative 3 is where we start our graphing. So we come down 1, 2, 3. So this red dotted line, where we see it's not a solid line, and we look here, well, it doesn't say equal to. And so it starts at negative 3, and then it goes to the right one up 2, to the right one up 2. You can see I keep ending up back on this line. So that's my slope to just the 2. So when I take a look at this second equation, I have changed it to look a little bit different. So my y is equal to negative 2x plus 2. So I'm going to start at the plus 2, but it says negative 2x. So I'm going to go down 2, 1, 2, step out 1. There, I'm back on the line. So I go down 2 to the right 1. I ran 1. So it puts me right back on the line. So this equation is in blue. So if we come back over here, we have y is less than 2x minus 3. We said that was the red one. We're not surprised. Y is less than. So that means everything on this side is yellow of the red line. And when we take a look at the blue line, it says y is greater than. So everything above the blue, above the line is blue. So this whole side is shaded blue. And when you take blue and yellow and mix it, you can see it becomes green. So that's what the coloring in the picture is telling you. This green is where you have yellow and blue. So these points satisfy both equations. The system of solutions lie in the green region where the graphs overlap. So we check our work and we pull out a point out of that green section, and if you go to the X on 3 and 0, that ordered pair is from the green section in the picture, and it satisfies both. We want to see if it satisfies both inequalities. So here's one of my equations. So I substitute in 0, I substitute in 3, so we have 6 minus 3 is 3, 0 is less than 3, check, that does satisfy that equation. So here we have the 2x plus y, we're back to the original equation. We put in the 3 and the 0, so 2 times 3 is 6. 6 is greater than 2, and that's a true statement, so check, that also works. You can combine your knowledge of linear equations with your knowledge of inequalities to describe a graph using a system of inequalities. Problem 2. Writing a system of inequalities from a graph. What system of inequalities is represented by the graph below? So we take a look at the graph and we can see we have two different lines in there. To write a system that is represented by the graph, write an inequality that represents the yellow region and an inequality that represents the blue region. So we start out with the blue, and we notice that it's going through -1 on the y. So we have y is equal to -1. And now we know we're going to put an x in there because we see the slope of the line. So we go to the right one, up one, right one, up one, and I keep coming right back. So I could stop right there, or I can put the 1 in there. But it's mathematically correct just to leave it blank, because you could see there's only one x there. Okay, so for my red line, I need to find where my y-intercept is. So 1, 2, 3, 4, 5. We're crossing at the +5. And now I need to check my slope, and I can see I went down 1 and I'm not on the line, so I'm going to go down 2 and I am on the line. So I went down 2, but I need to see how far I had to run to get back on the line. 1, 2, 3, 4. So it says, you can see at the half, all I had to do was run 2 and I would have been back on the line on the first one. I could see that by simplifying right here. So I can go down 1, out 2. Now that I've written the equations, I'm going to look at the line. And I see the blue line where I was going through -1. Above the line is shaded blue. So that means y is greater than, and it's solid. So it's greater than and equal to. But on the red one, it's shaded below the line. So that one's less than, but it's not a solid line. So it's only less than. So I'm going to change that to less than. Okay, to write the system that is represented by the graph, write the inequality that represents the yellow region and the inequality that represents the blue region. So now we're going to look to see how your book is telling you to do it. This is the exact same thing. The red boundary line is y is equal to -1/2 x plus 5. So we're coming in at the 5 on the y-intercept. We go down 1 and out 2, so there's our slope. So we know that's the region. And this says equals to, but this line is not a solid line. And then we are also shaded on below the line. So there's our y is less than, because it was shaded below the line. If we go over to the blue, we have our y is equal to, but we notice that the blue is shaded above. So here we have y is greater than or equal to x minus 1. And you can see there's the -1. We'll go to the right one, up 1. So it's a positive slope to the right one, rise 1. The graph shows the intersection of the same y is less than to -1/2 x plus 5 and y is greater than or equal to x minus 1. So all they're asking you to do is write the two equations in the graph. You can model many real-world situations by writing and graphing systems of linear inequalities. Some real-world situations involve 3 or more restrictions, so you must write a system of at least 3 inequalities. Problem 3. Using a system of inequalities, time management. You are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least 1.5 hours on homework. What is a graph showing how you can spend your time? Well, we know at most 6 hours playing basketball and doing homework. Less than 2 hours playing basketball and at least 1.5 hours doing homework. And you need to find different ways you can spend your time. Plan, write, and graph an inequality for each restriction. Find the region where all 3 restrictions are met. Let x be the number of hours playing basketball and y be the number of hours doing homework. Write a system of inequalities. So if we add our hours of basketball and our hours of homework, we're going to get at least 6 hours total. And then for basketball, we don't want to do more than 2 hours. So x can be anything less than 2 hours. And then for homework, we have to do at least 1.5 hours of homework. So y is going to be greater than the 1.5. So we graph each of these lines. So here, if I cover up x and make it 0, y is 6. So I come down to 6 and I plot my point right here. And I'm going to do that with a pen. So there I plotted that point right there. So I come back over here. If I cover up my y, x is 6. If I cover up my x, y is also 6. So I can come up here and plot my other point, draw my line. That one was really easy. Now I have x is less than 2. So I know everything is going to be less than 2 when x is less than 2. So I draw my line at 2, but I break it apart because it's going to be less than 2. And then we have y is greater than 1.5. So I come up to 1.5 on the homework and I draw my line, and it has to be above. So I'm going to draw an arrow here, everything above it. For basketball, it had to be less than 2. But I know the two of them together have to be anything below that line. So you can see all the arrows are pointing to the same section. So we can pick anything inside of there to satisfy these 3 equations. And they call them restrictions. Your homework number 7, determine whether the ordered pair is a solution to the given system. Just like yesterday. Take your ordered pair, put it in. It needs to work for both equations. Yes, it does work, or no, it doesn't work. Number 10, solve each system of inequality by graphing. So here you're going to graph, so pay attention to the instructions. Graph these two and make sure you shade it. And you do want to have 2 different colors shading. Maybe a pencil and a pen, or crayons, colored pencils. Write a system of inequalities for each graph. So when you get to 22, now you're going to write the system of inequalities. You're going to write an equation for your red line here. You're going to write an equation for your blue line here. So you can go back into the instructions to get the instructions played to you again if you need to.